So far we've learned about the theory of overflow. Today I'd like to have a look at some examples in real life which are of bugs which are caused by overflow and give you some context as to why we should care about it and why we have to deal with it. So let's have a look. The first one is the Ariana 5 explosion. Now this was a rocket launch in I think 1996 by the European Space Agency. The rocket broke up in the air after its maiden voyage, and this was because of an overflow error. They tried to convert a 64-bit floating point number into a 32-bit or 16-bit sign number. And when they did that, the translation obviously couldn't occur because there wasn't enough information to represent this in the 16-bit signed number. And the rocket then performed a dump of diagnostics for the overflow, which was incorrectly hooked up to its motoring system, causing the rocket to veer wildly off course and break up in the air. Now, this was a small overflow issue which caused a $500 million rocket to break up in the air. Another place where we see tons and tons of examples of overflow is video games. You probably encountered some of these before if you're anything like me, but here are some examples. So in Super Mario Bros, one of the issues that we had in that game was that I think it was an 8-bit number that was used to represent the life system, but it was a sign number. So if you got more than 127 lives in Super Mario Bros, then you would die, because it would wrap around the top and come back down as a negative number. So if you tried to get as many lives as you could, you might wind up while dying in that game because of overflow. Another one is Final Fantasy VII, where in one of the boss fights, you can kill the boss by healing it. So if you heal the boss past the upper limit of the positive number, it wraps back round to 0 or to minus a massive number, and the game thinks that the boss has died. So you can get past the boss without actually having to fight it just by exploiting overflow. Another game where you could do this was in Pokemon Gen 1. They had different categories for whether or not a Pokemon was a slow or medium learner, as in it needed more XP to level up the same amount as a fast leveling Pokemon. But the way that they implemented this was to have a negative number to start with. So if you could get a level 1 Pokemon with with a negative amount of experience and then get a tiny bit of experience so that the number remained negative, it would then swap to being an unsigned number. So it would take this negative binary number, represent it as a unsigned number, and that would make it over level 100 immediately, just by exploiting the fact that we were transitioning from signed to unsigned. So it would go from a tiny negative number to a massive positive number. You see a lot of examples in video games. I'm sure there were some in Stalker Clear Sky. I think there was some in some of the Donkey Kong games. There's been loads of examples in video games. I think there was one in Diablo 3 which crashed the internal market of the game because you could exploit overflow to get an incredible amount of gold. There's really tons and tons in the realm of video games, which you might expect. It's all computer based. It's a lot of overflow to keep track of, especially in games where there's XP and things like that. Another example, or maybe a more frightening example, is a Boeing 787, where pilots would have to reset the electrical system of the plane regularly, because if they did not, it would cause overflow, which might wind up in loss of electricity to the plane. So what that would mean is whenever they were using the plane, it would deploy the little some sort of backup turbine system, which is used to generate electricity outside the aircraft. So you use the airflow to spin the turbines and generate electricity because the overflow has killed the internal electricity system, which is a bit terrifying. That's unfortunately been fixed, so we don't need to worry about that anymore, hopefully. But these are just some examples. This isn't anything that's accessible. I just wanted to give you some context as to why we might care about overflow in real life. It's obviously been quite a theoretical topic, and I find for theoretical topics it's better to have some context as to why you should care about this thing. Overflow is one of the more common errors you can have when you're dealing with programming. You'll probably see it a lot in your lives. It appears quite often because it's often not tested for, because the numbers that we have to have for overflow to occur can be massive. So we're unlikely at times to test such massive numbers, and so overflow is allowed to happen. But yeah, this was just a little video to give you some context as to why overflow is important. I hope you found this useful. Of course, if you have any questions, please do let me know. Thanks.